SwayamPrabha. Digital India. Educated India.
Welcome to the NPTEL online certification course on structural systems in architecture. So, we are now in the module number 5, the week 5, and this week onwards we will start the various types of systems, structural systems one by one. And in this week we will start with one of the very important structural system called the trusses and the space frames. The truss and the space frame are this particular week topic is again subdivided into 5 such lectures of half an hour each, and this one is the lecture number 21, and we will have the lecture topic as the introduction to truss. So, the following concept will be covered. We will start with the definition of truss, and then we will gradually going to see what are the structural concept of the truss, what is the benefit of the truss, and how the structurally the truss can be applicable in place of beam or other type of structural systems. Then we will discuss the type of trusses and the geometry of the truss, then the part of the truss, and also we will discuss the structural advantage of the truss. So, in the learning objective of this lecture, we will initially outline the concept of truss and all, and then the classification of the truss will be covered in the next, and finally it will give you something like that the geometrical pattern of the parts of the truss, how it is important and how it is actually illustrate. So, as you see the truss is one of the very important and very the popular kind of structural systems every day in some of the buildings or some of the built environment. We have seen that the truss is used as one of the major structural systems, and this structural system this truss is made up by some triangular units or the triangular component, and mostly those members, triangular members, are straight members and they are joint in some typical points, and that creates the node and joint or the node, and from the node the various parts of the triangular unit are straight. This is also called as a open web girder. The girder, as you know, we have discussed in the earlier lectures that it is a kind of a deep beam. So, it is a open web girder where the webs are open, and why the webs are open and all we will discuss in the next few slides after that. And it is a vector active system because as you know, the vector is having a kind of a direction and also a magnitude of the force. So, the force and the magnitude and the direction of the forces will be active in a particular truss system in a depending upon the direction and depending upon that triangulations of that. This is normally pinned. So, we assume that this particular junctions of two straight portion of the truss is pinned, and it cannot take any kind of moment or so. In practice reality it is not pinned, but it will take some kind of a moment, but it will be the load will be transferred such a way that in that particular node that the mostly it will give you either the tensile force or maybe a compressive force. So, this last but one this point is very important while analyzing any kind of a truss, that the loads are on the nodes, and if you see it is on the nodes, the components of the forces in the members are either tensile or compressive. When all the forces are applied in the same plane of the truss, so truss can be of the two dimensional truss or the three dimensional truss. The two dimensional truss are the trusses whose are the members are in a particular direction and the force is also applied in the same direction, and that comprises of the no bending or those kind of a scenario, and only pure axial forces will be the result, and those are the plane truss or the plane truss or the 2D truss. And in case of the three dimensional truss, that is called a space frame, where also we will get the forces as a axial force, but the trusses are act as a three dimensional in nature. So, the members are not in one confined in one plane, it is in the 3D plane. We will discuss the space truss in the last lecture of this particular module. The first 4 lectures will be based on the truss and two dimensional truss, and we will see the how gradually in the subsequent lecture that how the trusses will be taken into for the analysis and then comparative analysis of 2-3 type of truss also. So, let us first discuss the structural component or the concept of a particular truss. So, I have started with a beam, and this beam is a having two pointed load, and this pointed load are supposed to be at 1/3 distance. So, you know the bending moment diagram is a trapezoidal diagram. I have deliberately drawn the bending moment diagram in the negative side to look into something, I mean some basic principles to understand that how that will be governed out. And also it is very important that the SFD is something like this, and we have discussed this thing many times in the earlier lectures, and in the middle 1/3 portion there is no bending moment. So, this middle 1/3 portion is under the pure bending, and the top portions the side portions are under the shear also bending. But if you look into the bending moment diagram, so what we understand from that, the central span is having the high moment and low shear, almost low shear in the sense almost 0 shear in that, and the central span need to have the more depth, because as you have to encounter a high moment in the central portion. So, you have to increase the depth, because as you know the distance between the fiber distance between the beam or the section portions has to be higher to encounter the moment and to reduce down the bending stress in the top and bottom fiber also. So, if this is so, we can say that this particular girder has to be designed something like this. A beam has always going to be a equal cross section, but the cross section in the end part is not that much efficient in the, I can say the efficient, because it do not encounter that much amount of bending moment. So, the central portion need a high amount of depth again, and this depth is actually responsible for resisting moment, and wave is responsible for the resisting shear. So, at this portion is called the wave portion, this central portion is called the wave portion, and this portion is required to be responsible for the shear. But if you remember in the earlier slide, we have seen that in this central portion of the beam there is no shear. So, in this portion we can make it open, or I mean what we can do is that we can save some amount of materials. This portion we can open it and we put some material in the top and also in the bottom to encounter the bending moment, because the bending stress diagram, as you know, it will be something like this. So, you require high amount of material at the top and bottom, and as the shear is 0. So, we can open out the sections, open out the portions of the wave. So, the high depth, as I have written over here, high depth with open wave typical of structural member is more suited, more economical, more efficient in that way to carry the load. So, if I take this particular the preposition in the next slide, for a pointed load or for a other than that a big kind of a the span, when there are heavy or huge amount of bending moment comes in the central portion. So, I need a that higher depth, you need a higher critical depth. But again the higher critical depth means I need material at the top and the material at the bottom, because even if it is higher, I know that the stress diagram will be like this, and you required high stress value, you have to encounter the high stress value at the top and bottom. So, you required material at the top and bottom. Centrally we may not require that much, I mean you required, but not that much of the material. So, what we can think of? We can think of a kind of a structural system which I have just drawn. It is a very theoretical kind of a structural system. So, what I did, I follow the bending moment pattern of a uniform distributed load, or maybe a pointed load which is parabolic, or maybe a triangular on a simply supported beam of length high length L, and I take out some of the portions from the central portions and make it open wave, because wave I do not required, I have to have the central portion have less amount of shear force, but high amount of bending moment. So, the high central depth with the open wave type is more efficient, that what I have discussed in the last slide also in a case of a 2-point load, this is for the 3-point load. So, this particular type of the preposition or this kind of a this conclude this actually this type of the structure conclude to be a truss kind of a structure, where you have seen a triangular thing in the central portion of the particular truss or the particular span. The portion the depth of the portion is high, and it is having lot of the empty portions, triangular empty portions, which is your the open wave kind of a portion. So, that is why truss is called as a open wave kind of a open wave kind of a the structure, or open wave girder kind of a thing. Now, the next point is that the why I need triangulation. Without if you see the truss, it is all triangle, small pieces of triangle. Why it is triangle? Why not it is square, or why not it is pentagon, or any other shape? Why it is triangle? Let us discuss that why the triangle suits best in case of the load resisting phenomena. See, I have drawn here there are 4 bars, and those 4 bars are actually pinned. Suppose you imagine there are 4 ice cream sticks, and those 4 ice cream sticks are joined by 4 pin with the table pin or something like that, office pin or something like that. So, it can be actually it is a very flexible kind of a scenario. So, for rigid, those the members are rigid, and it create a square with the pin, and suppose the bottom one, the member is actually paste it in a particular table, or maybe fix it with a particular in a particular platform. Now, if you put a load here, this load a kind of a lateral load, what will going to happen? This will change its shape. So, the square will change to rhombus kind of a. So, it is very easy, if this is very small, a small load will going to give a small changes in that particular shape change. So, shape will going to change without difficulty. So, it is a easy deformation will occur, and no change in length of the member. So, the square transform to a rhombus. But if I put the fifth member, that is a diagonal member, maybe in this side, or maybe from the top right to the bottom left also, it is same. If you introduce a fifth member, and if you want to push it and try to make it a kind of a small deformation, it is not so easy. Why it is not so easy? Because if you want to make a deformation, so this diagonal member has to be shortened. You see, this diagonal member of a square will be shorter in this case, in case of a rhombus, or if you have put it like this, it has to be elongated. So, it is quite tough. I have written here, wrote here, it is quite tough, and the transformation from square to rhombus is quite tough, and the diagonal member need to be shortened, or sometimes it has to be elongate if I place the diagonal in other way around. So, what happened here is that because of the introduction of the fifth member, the whole system divided into two triangles, and as this triangle, if you cannot actually make a change in the triangle or deform the one edge of the triangle very easily, because if you want to deform it, at least one of the side of the triangle has to either compress or it has to be elongate, and that is going to be tough for you, and that is why a particular the triangulation will be very stable in sense. So, from the triangulation is very much stable. This square or maybe any type of those polygon, this pentagon or any kind of polygon will be much easy to change its shape without any kind of deforming of the body or so in a member or so. So, there are a lot of examples in the nature also. The wings bone of the vulture, that is the one of the strongest bird we have ever seen in our nature, is, if you see, it is like a truss. So, it is very strong, it is just these wings are very strong and truss. So, conceptually it can be seen like a kind of a truss, which we have mostly seen in the railway bridges or so. And if you see a mechanism of the truss, I have drawn here. If you have the loads, and this loads actually placed in the typical nodes, and this load will now going to the act on the as the member are placed also. So, it is very important that I have to choose the right inclination of the member to distribute the force eventually and evenly through these members, and by virtue of the nodal forces, the external forces applied at the nodal points. And the pattern of the geometrical pattern of the truss will definitely going to provide a impact on the total system design and total the assessment of the load and final design of the each and individual member. So, now let us go for the classification of the truss. Truss are majorly classified into two types. I have already told you, one is called two dimensional truss or plane truss, another called is the three dimensional truss or the space frame. We will discuss it in the last week, or not last week, sorry, the last lecture of this particular week. Now, the plane truss are also subdivided into two further categories. One is called pitch truss and another is called parallel chord truss. Parallel chord truss are mostly used in the bridge. Of course, those are also used in the buildings, but the pitch truss is mostly used for the large span roofs. The pitch truss is something like this pitch, that is, it is inclined, it is a triangular shape, so it looks like a triangular shape, and it is often used as a roof construction. And there are plenty of the types of examples or the typical geometrical from the geometry point of view. There are examples of the pitch truss, and they are applied into various types of building, various needs to cater and all. So, the two most very simple type of the pitch truss is called as a fink and the fan. You see, the fink and the fan are almost same, only in the fan there are the vertical members are introduced extra, and this is called fan because from this point of view it is actually going to diverge, the three members are diverging. And there are other type of also which mostly go with the vertical members, that is called Pratt truss or the way truss. So, thus the difference between them is just the orientation of or inclination of this to the inclined member. So, if the inclined members are changed, the Pratt changes to a kind of a truss. Whereas, there are now they are for a larger span to take, you have to increase the number of elements, number of triangulations, and mansard and the fan fink trusses are also taken from that particular point of time, that when we go for the high amount of the large span has to be taken. So, these trusses, those are for the small span, like mostly it is 10 meter or something like that, 10 to 20 10 to 12 meter or that. If it is more than 12 to meter, 15 meter or more than that, then we have to go, or more than 10 meter if you can say, then we have to go for the this fan truss, fan fling truss, or the mansard kind of a truss. So, here also you see it is mostly inclined, these fan flings are kind of inclined members, and here it is mostly the horizontal and the vertical members. That is the visual change what we can see from this particular the systems are. Okay, so these are the mostly horizontal and the verticals, whereas there are typical type of trusses are also available. So, the scissor truss or the gambrel truss is also there. So, you see it is the probably the same type of the notations, or probably the same type of geometrical formations, but the pattern of the external roof is changed in the gambrel, and the pattern of the bottom pattern is also changed in case of the scissor. So, due to the change in the geometrical pattern, the name also changes. There are other type of truss like the monopitch truss and the dual pitch truss. As you all know, the monopitch is it is having inclination in only one direction, and here it is the bidirectional. So, that is dual pitch. So, both the trusses are very much useful in the industrial building mostly, and these trusses are going to have some other criteria. They can actually allow some kind of a light in the industry from the north point of view in the northern hemisphere. So, this mono pitch truss or the dual pitch truss is also called as the north light truss also, because it is used in the industrial building, and these portions will face north. These portions can be faced north and can allow the lot of the diffused lighting. There are trusses like bowstring truss, which is a bow like a bow, and it is kind of a circular in the top and flat in the bottom, and it has a zigzag pattern of the internal member, also create the triangulations. Those are applicable in some of the railway stations, large railway stations like the Howrah railway station in Calcutta, and all the other kind of a thing. You the large has to when it has to cater a large span. Attic truss is also useful. This is a portion has been created in the truss to store some material. Sometimes it is applicable in the houses or the small homes, and people typically put some of some article, the luggage or something like small things over there, and also this space will be creating a kind of the buffer space for the thermal barrier or the thermal cushion kind of a thing. So, this is called the double inverted kind of a truss. So, this is inverted, this is a single truss if you see from this side, okay, and this is inverted, and that create a kind of a double inverted kind of a truss, which is very much like to be like a fan fling kind of a truss, but there is the central member is missing over here, and these are called flat and the sloping flat kind of a truss, which is also very much useful for the long span structures like the warehouses, or maybe in the stadium and all, where you can go with this kind of a flat or the sloping flat kind of truss. Also in the auditoriums also we can see this kind of truss. Next, in the parallel chord truss, where these two top, it is not the inclined, it is a parallel chord. So, the chord top and bottom chords are parallel, and in between there are triangulations are done. So, it is mostly used for the bridges, is for the floor joist for the buildings also. So, the auditoriums and the multi-storied building with some kind of those kind of frames can be think of with this kind of parallel kind of a truss. There are too many types of parallel kind of a truss, where one is these two are popularly called as a lattice girder, and this is called the Warren girder. So, you can see from the figure that its lattice are actually the diagonals and the post kind of a thing, verticals, and the Warren girder are the inclined kind of a thing, and you can have the K type girder or K type wave, the diamond type wave, the floor girder, and different formations. Sometimes to make a extra rigidity we can put extra member here also. So, that is not a can create a little bit of a rigidity if you expect some additional kind of a load or so. So, let us discuss some of the truss geometry. So, as we know, it is an inclined or pitched roof. So, the span of the truss is measured from the support to support. So, that is the span of the truss, and we do not want to have intermediate support, because we go for some kind of a long span application. Suppose it is for a the railway station, or maybe for some kind of the auditorium, or maybe a stadium, kind of a small stadium, the swimming pool or something like that. So, in that we do not want to interact with some kind of more the members. So, it require a long span. So, support to support is long, it as the span has to be catered with the rise of the truss, which is the central, the vertical most point, the depth of the truss is called the rise. So, these two are the two elementary geometrical dimension for a truss. So, you first has to decide that how much is my span and what should be my rise, what should be the ratio between this L and R, that is very much important. We keep around 1:3 or 1:4, something like that. So, where 1 is your the rise and the 4 or 3, those are your I am sorry, the 1 is your rise, yes, 1 is your rise, and the 4 or 3, those are your the proportion of the length. So, we can also find out by virtue of that this angle, because from that particular the geometry, because I can find out by if I know this is R and this is L by 2. So, I can know this particular angle, and also the pitch truss has a gradient, and this gradient also I can find out in 1 in n. So, 1 in some number. So, suppose if I have the span of the truss is, this is suppose 12 meter, and this is suppose the 3 meter. So, this half length is 6 meter. So, you can easily find out this 6 by 3. So, this is 26.56 degree is the slope, and also pitch is 3 in 6. So, if you go 6, you will lift by 3. So, if you has to lift by 1, then you have to go by 2, horizontally go like 2 and then you go 1. So, that is the pitch, or that is given in a time of in term of the 1 in some number. So, that is the geometry, and this particular any truss has to be the raised, this is the internal the skeleton of the structural system, but we have to put some roof over there, right. So, a roof and a truss has to be the roof is placed on a purlin called those members which are actually connecting the roof to the truss. The connecting members are the purlin, and you see these purlins are placed on the nodes, not internally. It will not going to place internal points, only in the nodes, and whatever the loads comes, that will actually come into this particular point, and that the load is transferred to the particular truss. So, the various parts of the truss. So, if you see a truss, if you see an inclined truss, these two are called the rafter, these two are called the rafter, this is the rafter, these two are the rafter, this is the tie beam. So, tie beam and the rafter actually gives you the first big triangle, and this triangle will be subdivided by the smaller triangle by post. So, this is the king post, the highest vertical member, then this is the queen post, then this is the rafters are, these inclines are called the sturt, these inclines are called the sturt. There are gusset plate for the connection, we will discuss the detail in the last the fourth lecture, and those are the supports and all. Whereas, in the parallel chord truss, we have the upper chord, we have the lower chord, and we have the diagonals, and we have the post. This very simple. So, the structural advantages, it has lot of advantages. This truss can be assembled by virtue of the individual member. So, it is very easy to erect and very quick to install. It has provided high span solutions like stadium industry, as I told. It is lightweight construction, because lot of things are in waves or open waves. So, there are lot of less amount of weight, self weight is very less. with compared to that much depth of beam or so, and it saved time and cost. So, I think that is all for this lecture. Those are some of the references I took, and as I know, as I discussed, Truss is considered as a vector active structural systems, is widely used structural forms providing long span solutions in buildings used for the supporting roof. It has been used. So, in the next lecture we will discuss the analysis of truss part 1. Thank you very much.